Hello and welcome to Life at Pulse. Today we will go over an AS level chemistry paper. This is the first lesson on this paper. It's a paper 2, level structured questions, October-November 2020, paper 21. And we will start from scratch with question 1. So this is the first lesson of a series of probably 3 to 5 lessons where we will complete this past paper. So the first question is about ionization energies, specifically the first ionization energies of different elements. And we can see the graph here. The graph shows the first ionization energies of some of the elements in group 2. So we see from the first element down to the fifth element in group 2, beryllium, magnesium, calcium, strontium, and barium. And we can see that the ionization energies are decreasing when we go down the group. Okay, let's see A. Write an equation for the first ionization energy of magnesium. So let's quickly recap the definition of ionization energy. So the first ionization energy. Okay, so definition. We have here first ionization energy is defined as the energy required to remove 1 mole of electrons from 1 mole of gaseous atoms to provide 1 mole of gaseous single-charged ions. So important in the definition is that we are looking at the energy required to remove the electrons in the gaseous state. And that means we need to include that as well in the equation, and it actually states that here as well, include state symbols. So let's write it down. For magnesium we have Mg, and magnesium will lose an electron to form in the gaseous state. Oh, I forgot the state symbols. So Mg in the gaseous state. Let's actually change our color here to black, smaller. Okay. Mg in the gaseous state will give us Mg plus in the gaseous state as well, plus an electron. So this is the equation for the first ionization energy of magnesium. Explains the observed trend in first ionization energies down group 2. So as we already said in the graph, we can see that the first ionization energies are decreasing. So why is that? So for that we should have a look at the structure of the atoms of group 2, and can draw 2 maybe. So we have beryllium. Beryllium has an atomic number of 4 and mass number of 9, so that means beryllium has 4 protons in its nucleus. That's quite important here. So let's write the proton number in the center of our atom. And then we have 2 electrons in the first shell and 2 electrons in the second shell. If we look at magnesium, 12, 24 roundabout, and that means we have 12 protons in the nucleus. First shell, 2 electrons, second shell, 8 electrons, and third shell, 2. So that's enough for now. That should be sufficient to explain the decrease in ionization energies when we go down the group. So what causes the ionization energies? First of all, so whenever an electron is removed from an atom, it requires energy. That is the first ionization energy, when we remove the first electron. So why does it require energy? We have our positively charged nucleus, and at the moment we have 4 positive charges here in this nucleus, and these positive charges attract the electrons. So if we want to remove an electron, we need to overcome this force of attraction of the opposite charges, since electrons are negatively charged, as you know. Now, let's say we want to remove this electron here, and in magnesium we want to remove that electron. We know as well that beryllium will require more energy. So why is that? The first reason why it requires more energy to remove the electron from here compared to here is the distance from the nucleus. As we can see, we say the nucleus is here, the distance from here to here is shorter than the distance from here to here. Being further away from the nucleus, this electron, that means that the forces of attraction of the positive charges will be weaker. The electrostatic force, or the strength of the electrostatic force, decreases with distance. So that is the first point that we can write down. The distance of the nucleus and outer shell electrons not decreases, increases. Increases. And here it already says down group 2, so we don't need to mention that. We are going down the group, distance of the nucleus and outer shell electrons, so between the nucleus and outer shell electrons, not off between. So the second point is that okay, so we could argue against this point by saying, well, but wait, magnesium has 12 positive charges, whereas beryllium has only 4 positive charges, and 12 positive charges should definitely attract the electrons more strongly than 4 positive charges. Now, the counter-argument to that is that the outer shell electrons, they don't experience the force of the full positive charge of the nucleus. Why is that? Because of the inner shells that contain negative electrons as well, and they have a so-called shielding effect on that positive charge. So it's like that, as if these electrons on the inner shells cancel out some of the positive charges. And we can cancel them out one by one if we simplify it. So we have a total, as we already said, 12 positive charges in magnesium here. And we have on the first shell 2 electrons, so we have 2 negative electrons of shielding from the first shell, and then we have 8 electrons that shield in the second shell. So 8 electrons shielding. That means we have an overall of 2 positive charges that will affect the outer shell and cause the attraction of the electrons. If we look at beryllium, we have a total of 4 positive charges, and then we have the first shell with 2 electrons, and then the second shell is the outer shell. So here as well we have a total of 2 positive charges affecting the outer shell. So that is basically the same in both atoms. So the charge that affects the outer shell is basically the same in magnesium and beryllium. So we have, and that will further increase this shielding when we go down the group, because we add another shell in calcium and we add another shell in strontium and so on. So we have increased shielding. And together we can summarize that this will cause a decrease in the nuclear attraction. And that means that causing the energy, first ionization energies to decrease down, group 2. Okay, let's go to the next question, C. The second ionization energy of beryllium is 1757 kilojoule per mole. Explain why the second ionization energy of beryllium is higher than the first ionization energy of beryllium. Okay, so that should be not too difficult. If we think about this, okay, so let's say we have removed 1 electron. Now we have a total of 4 positive charges, but only we actually have positive ion here. We have a total of 4 positive charges, but only 3 negative charges. Again, regarding shielding, we will have 2 inertial electrons after shielding. We will have 2 positive charges that affect the outer shell, with only 1 electron remaining in it. Which means instead of having 2 positive charges that attract 2 negative electrons, we have now 2 positive charges that affect and attract 1 negative electron. Which means after we have removed 1 electron, the nuclear attraction increases. So we have a greater or increased nuclear attraction. So what else changes is not only that, or we can actually continue to look at the effect of this situation, having 2 positive charges that affect 1 outer shell electron, which means we have a stronger attraction. So what does this do to the ion? This causes the electron to be attracted more strongly to the nucleus, and what happens is this electron will move further towards the nucleus because the nuclear attraction is stronger, which means our ion will be smaller. The second shell moves closer to the nucleus. Being closer to the nucleus, that means that the electron has to be removed from a smaller ion. Okay, let's finish this lesson for now. First question about ionization energies. First ionization energy mainly. I hope I helped you understand the concept of first ionization energy better, and you have a better understanding after this lesson of this topic. If you do, please consider to subscribing to our YouTube channel, because this will allow us to reach more people like you that need help in their preparation for their A-level or AS level exams. I hope to see you for the next lesson, where we will go over question 2 and eventually question 3. All right, until next time, have a good day.